Another thing we can improve here is this reducer function. A lot of people don't like switch case statements, and they're not comfortable with writing this kind of code, an immutable update pattern. This is where we can use Redux Toolkit. With Redux Toolkit, we can create a reducer. In that reducer, we're not going to use a switch case statement, and we can write regular mutating code, just like how we code outside of Redux. Under the hood, Redux Toolkit uses immer, so the mutating code that we write automatically gets translated to an immutable update pattern. Let me show you. So on the top, let's import another function called create reducer. Now, we call this function. This function has two parameters. The first one is the initial state. What is the initial state here? An empty array. So we pass that over here. Now, the second parameter is an object that maps actions to functions that handle those actions. Let me show you. So here we pass an object. In this object, we're going to have a bunch of key value pairs. Our keys are going to be actions, and our values are going to be functions that handle those actions. You can think of this as a mapping between an event to an event handler. Here are a few examples. So what are the actions that we need to handle here? One of them is the bug added action. So our key is going to be bug added. Now we map this to a function for handling this action. This function should have two parameters, state and action, just like a regular reducer in Redux. So here we have a function. Now in this function, we can write mutating code. So what do we want to do when a bug is added? We want to push this object, this new bug, in our array of bugs, right? So I'm going to copy this code from here. Now here we type state.push this object. As simple as that. We don't have to use the spread operator anymore. Under the hood, Redux Toolkit uses immer. So this code gets translated to an immutable update pattern. Remember immer? Let me refresh your memory. So in immer, we have a function called produce that takes two arguments. The first argument is the initial state, and the second is a function for updating the initial state. So this function is going to take an argument, let's call it draft state. Now here we can write mutating code. So we can write draft state.x equals 1. Now this object is going to be a proxy, so it's going to record all the changes we're applying to it, and then immer is going to apply those changes to a copy of the initial state, okay? So in this case, this function that we have here is actually the second argument of the produce function. So Redux Toolkit automatically passes this function to immer for implementing an immutable update pattern, okay? So let's delete this code. So this was our first key value pair. Now let's add another key value pair. So what is the other action or event we want to handle here? Bug resolved. So one more time, bug resolved. We map this to a function with two parameters, state and action. Now, how can we resolve a bug? Well, in our array of bugs, we want to find the bug with a given ID, and then we set its resolved property to true. So state.find index. Here we pass an arrow function. We want to find the bug with this ID, action.payload.id, okay? This returns the index. Next, we go to state of index. This gives us a bug object, so we can set its resolved property to true. We're writing mutating code just like how we code outside of the Redux world, okay? Now, what is interesting here is that we don't have to call this parameter state. We could call it bugs. Now look at our code, bugs.push this new bug. Our code is a lot more readable. One more time, let's rename this to bugs. So now we go to the bug at this index and set its resolved property to true, okay? So with this implementation, we are not using a switch case statement, and that means we don't need a default case either. One of the source of problems in Redux applications is when people forget the default case. So if you don't add this here, your reducer is going to return undefined for actions that it doesn't recognize. And this is going to cause weird issues in your applications. So if you use Redux Toolkit, you no longer have to worry about this default case, okay? So now let's delete this reducer. So our reducer is able to handle two types of actions, bug added and bug resolved. The name of these properties is based on the type we have specified here. So the type of this action is bug added. That's why this property is called bug added. So if we change the type of this action to bug created, we have to remember to rename this property to bug created as well. Otherwise, this reducer is not going to be able to handle this type of action. Now we have a problem here. We don't want to remember to rename this property every time we change the type of an action. So let me show you a better way. First, I'm going to undo the changes. So we have bug added. Now, instead of hard coding this property name, we can add square brackets to dynamically compute the name of this property. So how can we get the type of this action? Well, earlier I told you that an action creator has a type property that returns the type of that action. So here we can type bug added the type. Now, if tomorrow we decide to rename this to something else, let's say bug created, we don't have to worry anymore because with this syntax, we can dynamically calculate the name of a property. Okay, so I'm going to revert this back to bug added to be consistent. Now, one more time, let's replace this with bug resolved the type. So our reducer is ready. Now, the last thing we need to do is to export it as a default object. Save the changes. Our application is working. Beautiful.